Hi students, in this video we're going to start doing some geometric proofs involving congruence. This video is also meant to be an introduction to geometric proofs in general, but it will also talk about congruence and how we use it and also how we prove it. Alright, so after watching this video, you should be able to understand how to set out a geometric proof and also use a geometric proof involving congruence. That might mean proving congruence or using congruence to prove something else. Alright, so some things you have to recall from previous lessons. So the four conditions of congruence: SSS, SAS, SAA, or any variation on that, ASA for example, and then RHS. Those are four conditions of congruence. We're going to be using them to help in some of our examples in this video. And then, like we mentioned before in our last video, we need to remember the geometric axioms and notation for angles on a line or revolution, angles involving parallel lines, and angles in triangles. Now students, so in a geometric proof, what we're doing is using a set of statements that we can create ourselves or that have been given to us and using them to prove something new. So a proof should involve the following aspects. We need to start off with a statement of what we are required to prove, also known as an RTP statement. That's the first thing. Once we've done that, we're going to use a table like what we've got here, a statement and reason table, to talk about this, to list the statements, the geometric statements that are true, either given to us or provided for us, and associated reasons. Reasons could be words, like information that has been given to us, or it can involve symbols, like all angles of a triangle add to 180. Reasons could be either of those in our table here. And then once proven, once our RTP statement has been proven true, we sign off with QED. QED is Latin, Coere Demonstratum, and that just is Latin for it has been demonstrated or it has been proven. So what we're saying with QED is we've done what we've set out to do, we're ready for the next thing, if there is a next thing. You could think of it as a bit like a Latin mathematical mic drop to say, we've done what we set out to do, what's next? Alright, so students, let's use what we understand of proof now to go through an example. We'll start off with a simple one, then do one that's a little bit trickier in our next slide. So what we have to do, students, in this example is prove that the following triangles are congruent. So we've got our two triangles here, X, Y, Z, and A, B, C. So all we have to do is all we are required to prove, is that those triangles ABC and XYZ are congruent. Now remember, with our notation and our lettering, A and X should correspond. Looking at our diagram, A and X both have no markings on their angles, so they correspond. B and Y have one line around their angles, so they correspond, and C and Z have two lines around their angles, so they correspond. We've written our statement correctly. Now let's set up our table where we write our statements and then provide our reasons. So going through this one, the first thing we can say is that our line AB is equal to our line from X to Y, right? In both triangles, the lines have the one dash, and we know that that means they are equal. Now, what's our reason for that? Well, we were given that information, right? So the question that was provided for us in the diagram, it might also be provided for us in that written statement in our question. But regardless, that information was given to us. We didn't have to work it out ourselves. Similarly, our angle at B is equal to our angle at Y because, once again, that information was given to us by saying B has only one line for that angle, so does Y. Finally, in our third statement, our angle at C is equal to our angle at Z because, once more, our angle at C has two lines on it, our angle at Z has two lines on it. So that information was once again given to us. Looking at that now, students, we've got one side that is equal and two angles that are equal. That's enough for congruence. So we can say triangle ABC is congruent to triangle XYZ because of our rule SAA, which we know from our previous lesson is a rule for congruence. Now, where did we prove those things? Where did we prove that side and two angles are the same? We list those numbers and those lines that we used to prove those things in brackets. So in brackets here, we proved the side was the same in step 1, we proved the first angle was the same in step 2, and the third angle was the same in step 3. Then we end with QED, saying it has been proven. Now let's do another one, it's a little bit different. So using the diagram below, we have to prove that FG equals 10 centimeters. So following our steps, we'll do our RTP statement. The question tells us again, FG has to equal 10 centimeters. And that's what we're required to prove. Now, how are we going to do this? Well, notice we've got two triangles here. We've got DEG, we've also got FEG. So a good way to think about starting this problem is by saying, right, maybe if we prove congruence, maybe that'll help us. So trying to find your triangles and prove congruence is a good way to start. So setting up our table, we've got our statements and our reasons. All right, our first statement we can make is that DE and FE are the same length. Now, what's our reason for that? Well, once again, like in the last couple of videos, we can say that information has been given to us in the question. All right, now what else can we say? We can say the angles at D and the angles at F, they are also equal. Right? Looking at the diagrams, angle at D is 90 degrees, angle at F is 90 degrees. So not only can we say they're equal, we can also say they're 90 degrees. And that information was given to us as well. Now finally, what else can we say about these triangles? Well, this side here, EG, it's in both triangles. So how do we write that mathematically? Well, we actually just say EG equals EG. So EG is in both triangles, so it's the same line, so obviously it's going to be the same. And we say the reason for that, why does EG equal EG? It's pretty self-explanatory, but we still need to give a reason. We just say it's the same side, or even better, we say it's a common side. Right? We say EG is a common side in both of our triangles. All right, so looking at information, we've got a 90-degree angle. EG looks like a hypotenuse, and we've got another side. So we've got hypotenuse, a right angle, and another side, but that's enough to prove congruence. So DEG triangle must be congruent to FEG triangle. Those points all correspond, so they're written in the right order. And the reasoning we have for it is we've got a right angle, a hypotenuse, and another side. The lines that come from are 1, 2, and 3. And now with that, we can actually say that DG must then be the same as FG. And if those sides are the same, then they must both be 10 centimeters. Because remember, for congruent triangles, corresponding sides are equal. So we can just write in here, they are corresponding sides, and because we proved congruency in step 4, that means they must be equal. So QED, it has been proven. Alright students, so after watching this video, you should be able to understand how to set out a geometric proof and also use geometric proof in some proofs involving congruence.